For more videos, visit forthesakeofeducation.com. Alright guys, let's do this very easy problem that says a 4 kilogram sphere rests on a smooth parabolic surface given by this equation. Find the normal force it exerts on the surface and the mass of the block B needed to hold this in equilibrium. So basically you gotta look at the free body diagram of the sphere. You have its weight going down, you have a normal being applied this way, and you have the tension being applied at 60 degrees right here. You know that that tension is equal to the weight of the block B. So let me draw the orientation. Now the first thing that you want to find is this angle of this normal force is exerting. How would you find this angle? Well, very simple. When you have an equation, in this case it's a parabolic equation, and you wanted to find this slope at any given point, all you got to do is find the derivative of the equation at the point in which you're trying to find the equation. So the derivative of 2.5x squared is equal to 5x, right? And you know that the sphere intersects this slope at 0.4 meters. So dy dx at 0.4, you just got to replace 0.4 for the x, and you get that it is equal to 2. So 2 is the slope at which the sphere intersects this this slope. So that's 2. That means that if it's 2, this is 2, and this is 1, and this is an angle I'm going to call beta. That will be the slope. However, that's not the angle that we're looking for. That's this angle right here, theta. So let's find beta first by doing the tangent inverse of 2 over 1, which comes out to be 63.3, just about. Now if you wanted to find this angle, which is opposite to theta, beta, all you gotta do is do this angle right here is equal to 90 degrees minus beta. That will be the angle that is exactly pointed at 190 degrees from beta. So this angle is 90 minus beta, which comes out to be 26.6 degrees, just about. And that is the angle that the normal intersects the sphere at that function. So you know that the mass of the sphere is equal to 4 kilograms. Then you know that the weight of the sphere is equal to the mass times the acceleration of gravity, which comes out to be 39.24 newtons. Now that we have the weight, we need the tension and the normal that weight produces. So sum of the forces on the x is equal to 0. The normal, which is going to the left, times the cosine of 26.6 degrees plus the force or tension, I call it force in this case, times the cosine of 60 degrees is equal to 0. So you get that negative 0.894 times the normal plus 0.5 times the force is equal to 0. I'm going to call that equation 1. You know that the sum of the forces on the y is equal to 0. So the weight coming down plus the normal times the sine of 26.6 degrees plus the force times the sine of 60 degrees is equal to 0. So 0.448 times the normal plus 0.866 times that force is equal to 39.24. I'm going to multiply this equation, this whole equation. I'm going to multiply it by negative 0.5 and divide it by 0.866. And I'm gonna get this new equation that says that negative 0.259 times the normal minus 0.5 times the force is equal to negative 22.7. And I'm gonna call that equation 2. So let me make some space over here. I'm gonna rewrite equation 1 right below equation 2, and I'm gonna get negative 0.894 times the normal plus 0.5 times the force is equal to 0. So then I'm gonna add these two equations together. These two cancel out, and you get that negative 1.153 times the normal is equal to negative 22.7. Solve for the normal, and the normal comes out to be 19.68 newtons, of course. You can solve for the force by plugging that into equation 1 or equation 2. I plug it into equation 1 because it's easier, and you get that the force is equal to 35.2 newtons. The force being the tension of the cable. If the tension that's holding the cable, that's holding the weight of the block, is equal to 35.2, you know that that tension, which is equal to 35.2 newtons, is equal to the mass times the acceleration of gravity, which is equal to the mass times 9.81. So dividing that 35.2 by 9.81 gives you the mass, and the mass comes out to be 3.59 kilograms. Final answer for the mass, final answer for the force, and final answer for the normal force being exerted into the sphere. Please comment below if you want me to do any problems, and I'll be happy to help. Thank you.